and I'm affiliated with the University of Colorado Boulder in the Venture Partner Group. I'm also part of Spectrum X, the group behind putting the session on. Spectrum X, just for a little bit of background for those that do not know, University of Colorado Boulder is one of the academic institutions. Spectrum X is a consortium of 13 top U.S. academic institutions which have come together to form what we think is an extraordinary response to a request by the National Science Foundation to create and stand up a single national center for spectrum innovation. So as such, today's topic is right, dead center in those sites here. Just a few logistics before we get started. We are recording today's session, so just be aware of that if you would. We are scheduled for up to 90 minutes if we need to go that long or if there's a desire. And we'll be taking questions and comments from the audience and through the chat. So people, anyone on the session today have any questions, comments, anything at all, please put it into the chat and we'll be keeping our finger on the pulse of that. We will, I think Mike, who will be our moderator, will be keeping a close eye on those and we'll be going to those as appropriate. Also, our presenters today have assembled a pretty extensive list of very relevant reading materials for those who want to dig in after the fact to really follow up and learn more about this exciting, both the technology and the privacy side and beyond that as well, right? So with that, let me go ahead and introduce our panelists. I'll pause here for a moment. Great. Looks like we have a good turnout. So we are very, very blessed to have two exceptional presenters today with extraordinary expertise and credentials. I'll introduce both of them and then our moderator. I'd be surprised if everyone on the call does not already know Dale Hatfield, but he's currently the distinguished advisor at Silicon Flatirons and is an adjunct professor at University of Colorado Boulder's Technology, Cyber, and Policy program. Dale's had a very long, distinguished career both in industry and within the federal government, and now inside academia, where he was the chief of the Office of Engineering and Technology at the Federal Communications Commission, and immediately before that, he was the chief technologist. He retired from the FCC and government in 2000. But before joining the FCC in 1997, he was chief executive officer of Hatfield and Associates, where he had a very prominent role driving an interdisciplinary telecommunications consulting firm based in Boulder, Colorado. And before that, he was, Assistant Secretary of Commerce for Communications, Information, and Acting Administration for the NTIA. I could go on and on, but Dale brings well over 50 years, he's modest about that, of deep expertise. He's often called on by our federal government to help steer, to help inform, if not on a regular basis. Additionally, every 4 years when there's a new administration, they lean heavily on Dale's expertise, and we're so proud to have him on today's call. He'll be starting off the session today. Joining Dale is Amie Stepanovich, who is currently the executive director of Silicon Flatirons, which is part of University of Colorado Boulder. She's a nationally recognized expert in domestic surveillance, cybersecurity, and privacy law. And her primary purpose today will be to comment on the relevant privacy and other aspects that we might want to be keeping our eye on as we go forward with this really exciting technology. Amie previously served as a U.S. Policy Manager and Global Policy Counsel at Access Now in Washington, D.C., where she worked to protect human rights through law policy involving technology and its use. Prior to that, she was a director of the Domestic Surveillance Project at the Electronic Privacy Information Center. She has testified in both the U.S. Senate and House of Representatives. And additionally, which is this next part I have not seen before, and also before the German and Australian parliaments. Right? She serves as a board member currently to the Internet Education Foundation and is an advisory board member to the Future of Privacy Forum. In 2014, Amie was named in Forbes magazine's 30 under 30 leaders in law and policy. So please, and then let me turn it over to our, I am really thrilled to have Mike Dano moderate today's session. Right, Mike has been in the industry for a long time. I have personally followed him and would encourage each of you to follow his writing. He's covered the wireless industry for over 2 decades. First at RCR Wireless, and then at Fierce Wireless. Mike's, again, he's an avid Twitterer. So again, he's got lots of postings. So please follow him along. And so with that, it's my pleasure to turn today's event over to Mike Dano to get the conversation going. Mike?
Yeah, awesome. Thanks so much, Scott. Really appreciate it. Great intro there. And thanks all you computers out there for joining us. I really appreciate it. Hopefully this event will be beneficial to you. And so with that, I think we're really just going to launch into it. If we do have any technical problems, we'll just power on through it. I think we're all used to the whole Zoom thing by now, but I think we can expect at least one muted speaker. And if that does happen, we'll all just, we'll move along. But so following that introduction, we're just gonna get straight into it. I have a list of questions here that is lengthy, and I've got a lot of stuff that I'm interested in as interesting technology. But like Scott said, if you do have a question for any of our speakers at any time, a question or a comment, go ahead and type it into that chat button. The chat, if you click on the bottom of your screen, there's a button that says chat. Just go ahead and click on that and type in any questions or comments you might have for any of our speakers today at any time. And we'll keep an eye on that because we definitely want to answer your questions because I've got a bunch, but we want to get to yours as well. So with that, Dale, I'm going to give you the first and probably the most important question for our event today, which is, can you just tell us what this whole RF fingerprinting thing is? Give us the real sort of general explanation of what we're talking about today.
Sure, I'll try. And first of all, Scott, thank you for the overly generous introduction. I'm very glad to be here. I think, Tiffany, you were going to display a slide for me, and I was going to talk to the slide at this point just to get everybody on the same page if we could. Can you do that for me? No, it was the text slide.
I'm now having the technical difficulties.
All right, everybody take a drink. We've got our first technical issue.
This isn't working. Oh,
So
no. I'll get it, just a minute.
Well, or you could give me screen sharing and I could pull it up.
Okay. All right. Go ahead.
Thank you. Oops, if I can find it here.
My work setup is different than my home setup, so, and I practiced it. Doesn't want to cooperate.
There it is.
There you go.
Yeah, I thought I would start with this and display it on the screen and talk my way through it. I should say that I cribbed this from a number of different sources, so you might want to think about that. What we're talking about is, of course, RF fingerprinting, which is sometimes, as I say here, called physical layer identification or radiometry. And the key thing about it is that it can uniquely identify specific devices that have transmitters, whether it be a cellular handset or a Wi-Fi handset, without, and this is critical, without reference to the data content that's being transmitted. In other words, the data being transmitted could include call letters, addresses like MAC address, and this doesn't deal with any of that. It deals with the physical characteristics of the transmitted signal. As it says here on the next slide, these imperfections, these differences in what's transmitted are depend upon the depend upon unique hardware imperfections that are introduced either when the transmitter is manufactured, or because of variations in the components. You know, every coil is a little bit different than every capacitor and so forth. And so because of these variations, each of these transmitters looks a little bit different when you look at the spectrum it transmits. And they're so unique, essentially you can extract that information, those imperfections, and actually identify the device. Now, I'm focusing on devices. We're not identifying individuals, we're identifying devices. But most of us, for example, carry our cell phone with us almost every day, everywhere we go. So it's tightly tied to that. It becomes, according to the claims and from what I read, I tend to believe that provides a very reliable and robust means for identifying specific transmitters, just like ordinary fingerprints can be used to identify specific people. Like any, by not relying upon what's embedded, the content, that can all be hacked. And there's people on the call who are much more educated than that than I am. But basically anything in the signal, like the MAC address, can be electronically substituted a different MAC address and fool you or spoof you. And again, RF fingerprinting can recognize a specific transmitter even if the software has been hacked. Very important point. And let me just say one final thing before I not ramble on too far here, is the sweet spot, if you will, for RF fingerprinting is in authenticating a device, say a node or end user device on a network, in order to prevent, detect, and resolve impersonation attacks. Are you who you say you are? Let me give you a very quick example from that, then I'll stop. I am currently, I think, tied my cell phone to the Verizon cell tower. But we all know there's devices called, a commercial device called a Stingray, which, so you think you're connected to Verizon network, but you're not. You're connected to a device that may steal your IMSI information and then let you go ahead and complete the call. So one of the things, I would like to do is when I'm communicating with Verizon's tower, I would like to know it's Verizon's tower. And because, as I say, each transmitter is different, I could figure that out. Now, whether this is feasible, all that sort of, lots of questions around this, but that's the fundamental thing that I can do. I can make sure that whoever is communicating with me using a transmitter, it's the transmitter it's represented to be.
Got it. All right. Yeah, really interesting technology and a great high-level overview. So that's really good. Thank you. And I do see a couple of extra people joining, and I do see a few initial comments there in the chat section. So if anyone out there does have a question or a comment for any of our speakers today, go ahead and type it into that chat section, and we'll get to them here in just a little bit. And so Dale, I wanted to follow up a little bit with what you're saying, and maybe ask you to, if you could really generally talk about some of the applications of this technology. You mentioned, sort of a security element to it. Maybe you can go into that more, and then also maybe just explain, are there any other applications, that initial sort of top line applications that you're seeing out of this technology?
Yeah, I thought I might start out by sort of breaking the question into 3 parts. Let me give a non-RF example. Let's say that Amie, I can't see Amie's picture, but she represents that it's Amie. Well, if Amie doesn't sound like Amie, I don't have to have her picture and so forth. I say something's wrong. I am hearing somebody and their voice doesn't match. I walk into a room with a badge that says Dale Hatfield and somebody says, no, that's not Dale Hatfield. He doesn't sound like Dale Hatfield. So that's sort of a human example of what we're talking about. We're using the characteristics of the content. And I'm an old man, so I reserve the right to have an example from my youth. I learned Morse code at a very early age, and where you sent out the dots and dashes, and you did it with a manual key. Well, you could listen for the person's call letters, like I was W8NGG when I started out. You could listen to the call letters, but because everybody's tapped out the dots and dashes differently, I could recognize who it is without looking at the content of the message. What I was looking at was the characteristics of how the message was being typed out. Let me give you another example from land mobile radio. And this has been used, and I have sites to the information. In land mobile radio, you have repeaters that just take in a signal and repeat it and send it over a wide area. And of course, I can spoof that. I can pretend I'm somebody else. So for example, if this was a public safety two-way radio system, I could pretend I was somebody else. Well, one of the ways of making sure I'm not somebody else is by looking at that unique RF signature that I'm sending out and say, hey, this is supposed to be a police officer. It's not. It's somebody else, because we recognize we can recognize the handsets that are supposed to be on the network, and here's one that's not. So that's sort of a simple, some simple examples, but we can go into much more sophisticated examples to Mike when it's appropriate.
Sure. Yeah, I suspect we'll get there. We'll get down into all the nitty-gritty details in the time we have. Just real briefly, Dale, are you seeing any applications that are not security related, or is it primarily security stuff?
Well, I suppose we ought to be a little bit careful, Mike, how we're talking about security. I'm not talking about cybersecurity sort of the way that you would traditionally talk about it. I'm talking about identifying and prosecuting somebody who's jamming GPS, for example. That's what I'm talking about. In other words, if somebody starts jamming the police channel here in Boulder, I want to be able to what? I want to identify, first of all, who it hit, what transmitter it is, and I want to be able to prosecute them. I want to be able to go out, stop it, get it stopped, and what we would call mitigate the immediate interference, and then get the person prosecuted for transmitting. But to do that forensically, what I need is some proof that I could hold up in court, for example, and that can be this unique signature that the transmitter is putting out due to problems in the RF amplifier, all those sort of things that make the transmitted signal unique.
Great. All right. Yeah, interesting stuff. And so, as you explained, I mean, the ability to individually identify, people through the devices that they're carrying, such as their phones, is there's a lot in that. There's a lot to unpack there. And I know when I walk around, I always wear gloves and I cover my eyes so that no biometric scanners can ever find me, and I won't leave any fingerprints anywhere. I'm very conscious about my own sort of, being able to be identified Yeah.
Yeah.
When I'm doing all the illegal things that I like to do during the day. And so, Amie, I wanted to pass this question on to you about the privacy concerns specifically. I know that this is something that you've been looking at. So maybe you can just talk about, the privacy concerns around RF fingerprinting, starting at a very high level.
Thanks a lot, Mike. Sorry. And thanks to Scott and Tiffany, and huge thanks to Dale for having invited me. A note of caveat. So I am not a technologist or an engineer, and I get to rely heavily on Dale for that and the wealth of materials that he has shared. And if you're interested in this topic, I really highly recommend you browse through those, because there's a lot of information there that's really useful. So Mike, you asked about privacy concerns. I want to talk first. There's something about the framing of the term privacy concerns. You get asked about that a lot when you worked on privacy. What are your concerns? And I think it manifests this image of people who work on privacy kind of wringing their hands in the background, worrying and fretting. And I never like to portray that. What I tend to do is talk about the risks that certain technologies pose to individuals and to protecting their data and their privacy. And so there are a few attributes to RF fingerprinting that I think create or increase the risk of a privacy violation or an individual suffering a privacy violation. And Dale touched on these, but I just want to draw them out a little bit. One is that the technology can be very highly accurate, and you're seeing this accuracy go up over time, the ability to pinpoint the fingerprint to a specific device, either actively or passively, which means that you can have the device in hand when you're getting the fingerprint, but you don't have to. You can actually acquire it passively. It can be very hard to fool. And again, the direction this is going is that it's getting harder and harder to fool. It's not getting easier. So the technology at fingerprinting and then identifying to a fingerprint is getting better. Most people will have at least one device on hand at all times. There's a lot of people not on camera. I won't ask people to raise their hand as I would if we were in a room, but I imagine you have at least one device on your person or within like grabbing distance right at this moment, other than the one that you're joining this meeting from. And you might have 4 or 5. So this is really closely tied to your person. Dale compared it to fingerprints. I think that's going to be to human fingerprints. I think that's going to be a comparison that comes up a lot during this conversation. The idea of an RF fingerprint as akin to a biometric. At some point, I actually want to talk about what if an RF fingerprint is a biometric? At what point does technology become so entrenched in our person that it is just an extension of the person? These devices are expensive to replace. And you can't change the RF fingerprint of a device, at least not purposefully. There's evidence that it changes over time. So it can be used to tie to identity unless you want to constantly be replacing your devices, and then it would be like replacing the fingerprint. And finally, and I'm a little unclear on this, I might turn to Dale or to the people here, but the literature seems to suggest that the fingerprint is reflected not only in the device itself, but in the data, which means that the process of fingerprinting doesn't reveal the data. I'm not trying to say that it can reveal your phone conversation, but that fingerprint actually carries through to the data. So there's literature on it being used to identify pictures that were taken from a camera using the fingerprint of the camera flowing through. And I found that to be very fascinating, and am looking forward to seeing how that process and how the use of that technology in that way develops. And because of these attributes, there are 2 main things that we would worry about from a privacy perspective, that we would have concerns about. 2 main ways that increase privacy risks. The first is anonymity. If we're going to talk about this as akin to biometrics, then you talk about it as an extension of your person, as your identity, and that connects it back to the human. And the idea that we're not only carrying devices around, but that RFID tags can also be fingerprinted means that there are even more ways to de-anonymize or remove your public obscurity through this process. And the second is through location tracking. And so this is related to anonymity and the stripping of anonymity, but it's basically taking the identification of the device and adding over time. So you can track a person from point A to point B to point C. And so those are the two main risks that come up with this technology. And then I can talk a little bit about why those matter and the ways that we would think about those risks impacting the human and things to think about.
Yeah, I think we may want to go there right now, Amie, if you don't mind. So Dale, I wanted to follow up with you on sort of the parameters and some of the capabilities of this technology. But Amie, first, I think maybe we do want to dig in a little bit further into those privacy concerns. And I as I go about my day, I do not hide my fingerprints. I don't wear gloves or anything. But the concept of RF fingerprinting, particularly the tracking part of it, in my mind, is something that gives me pause. And so maybe you can talk about, like, what are we eventually going to have to shield our phones from transmitting RF in order to protect our identities? Or, I mean, what are some of the real world implications of this?
I mean, I think it's interesting. You could shield your phone, but can you shield a internet connected heart monitor in your body? Probably not, unless you're wearing a full body sheath. So this might not be something avoidable, as I said. So there are two main reasons, I think, to give why people generally should care about this. The one is the easy one, because it's the law. Privacy is protected in the US Constitution, at least via state action. It's also a human right. And Special Rapporteur David Kay with the United Nations has talked about how anonymity and technologies that promote and protect anonymity are crucial to the free exercise of many different human rights and constitutional rights, including the rights to speech and association. So if nothing else, there should be a care, because there's a legal requirement and legal obligations associated with that. But I think what resonates more with people are the normative thoughts. Technology is changing how we interact with the world. And I think it's safe to say where you are, how you communicate, these are linked to who we are, and things that or technology that can track your location or strip your anonymity interfere with that. And so first of all, I want to lay out, there's a theory called mosaic theory that says that you need very, very few points of location to be able to identify somebody from location alone. So even if you don't have that device to tie somebody to, I mean, we all have one house and one job. And, when we're not quarantined because of COVID, we go back and forth between them. And those are two unique identity points to each person for the most part. And so even with just those two identity points, you can often identify somebody from their location. I also want to talk about who you're communicating with, what devices you're using, this idea of when you're communicating, that can be content, how you use your device, where you are, that tells people something. So when Stanford was looking at just phone call information, me calling out to somebody and how long those calls lasted, they were able to identify very personal behaviors from simply looking at phone call metadata. They were able to tell when somebody was having an abortion, when they were buying guns, because you can see the pattern in phone calls that are being made, and the length reflects that. Similarly, with location data, if you know where somebody is, you can tell how their thought process is moving along, what their patterns say to reflect what is happening in that person's life at that given time. If they're going from a doctor to a pharmacy to a church, there are inferences that can be made from that information, and using machine learning and artificial intelligence, those inferences are getting more and more accurate as data is collected, and you can compare patterns across different individuals. And that information can't lie. So even if you were eavesdropping on somebody's conversation, they can say something that's not true. You have to parse it. You have to tell whether or not they're lying. The location information, where you are, is factual, non really controversial information. And so that doesn't lie the same way a human might. Another study shows that making surveillance, making the collection of data cheaper, easier, and more accurate means that it goes up. So what we see is as these technologies continue to evolve that make surveillance easier, the state actors use them more often and more frequently, and corporate actors use them more frequently. So this is maybe not brand new. Location tracking has been around for a long time. Demasking identity been around for a long time. But you have to pay attention to evolutions in technology and how that can impact how much surveillance happens. Also lowers avoidability. You can't escape the eyes that are watching you. Mike, you made this point. You're not going to walk around and cover up your device. And one last point is that those changes move faster for you if you are more vulnerable or come from traditionally marginalized communities. There are many, many reasons that any person would deem legitimate why you would want to avoid tracking or preserve your anonymity. If you're engaging in a peaceful protest, leaving behind the ideas of what happened in Washington, D.C. in January, peaceful protesters might not want to know people to know where they are. Journalists might have reasons. Mike, I'm sure you can think of a few. Whistleblowers might not want people to know who they're communicating with, where they are at any given point in time. On a personal level, if you're leaving an abusive relationship or engaging in a sensitive medical procedure, you might also not want to have your anonymity and your location stripped. So historically, these traditionally marginalized communities are the first and most deeply impacted by advancements in technology that allow more surveillance. And my last point here is we're not only talking about the United States. And so we're going to this conversation, I'm guessing, is largely going to be focused on the US. I know the law here much more. But once other governments and people in other countries get a hold of this, in particular authoritarian or repressive regimes, we have to think about how they're using it as well. And so this has to be an international conversation.
Great points, Amie. Thanks. Yeah, I really appreciate the idea of sort of bringing this home and making it tangible to to this conversation about what this actually means. And I like what you said about in a society like ours, we sort of we have an assumption of anonymity, and that's an important thing. And I agree. It's something that we sort of all take for granted to a degree, but it's something that eventually will need to be protected as technology evolves. So good points. And I also wanted to mention too, that I see there's more people joining. I appreciate seeing you all. And we do have some comments already in the chat function. If you want to access the chat, you can click the chat button on the bottom of your screen. And here in just a few minutes, we are going to get to some of the questions and comments that are popping up in that chat. So I'd encourage you to continue to tell us about how you're buying tinfoil outfits as you listen to this discussion. That certainly feels relevant. And so feel free to continue to put your comments and questions into that chat box. We'll get to them here in just a little bit. But before we do that, I actually had one more thing to ask you, Dale, about this topic of RF fingerprinting. I wanted to ask if you could just talk a little bit about the parameters of this technology as you understand them. Amie mentioned that, based on her understanding of RF fingerprinting, that there may be a way to identify, not necessarily look at the picture that is being transmitted, but potentially a way to see that a picture is being transmitted using RF fingerprinting technology. So I wondered if you could address that specifically, and then maybe just talk about, generally, when we talk about RF fingerprinting, how does this technology work and what are the parameters? Meaning, does it work on walkie-talkies? Can you use it for only cell phones, or can I also use it for my garage door opener? Are you watching what TV shows I'm watching with my remote control for my TV that's wireless? Like, maybe you can talk just a little bit about, what can it do all of those things? Can it do some of those things? Just your understanding of the capabilities there. And Dale, I think you might be muted. And if that's the case, let's all take a drink.
Darn, I missed the opportunity. Let me go to the comment about the picture. you can identify devices at different, using information at different layers of the protocol stack. What I'm talking about here is physical layer identification. But if I'm really want to get additional information, the camera in your phone is different than every other camera. There's imperfections. So I can uniquely go up the protocol stack and say, this is not only Dale's transmitting device, the video he's sending matches that device as well. So now I can build up my evidence. If I'm trying to, in a case of law, in a law, trying to prosecute somebody, now I've got some pretty strong evidence that this device is what was causing problems. And if you'll excuse me, Mike, I can't resist here a little bit of taking a position that this can be awfully important. For example, if I'm in a manufacturing plant and there's a device in that manufacturing plant, an IoT device, for example, I want to make pretty sure it's the IoT device that's supposed to be there. It's not being spoofed. Moreover, if I'm doing something like I'm in a healthcare facility and I have an insulin pump or something, I want to make pretty darn sure that that insulin pump has not been spoofed. If I'm in a correctional facility of some sort, I want to know, is there phones in the correction facility that shouldn't be there? Because you can do all kinds of mischief from inside the prison, as we know. And then probably the class is the GPS jamming. It's still there. It can cause so much havoc that we need to be able to, again, find and prosecute the person. Vehicular, when I'm talking to a traffic sign, am I really talking to the traffic sign, or am I talking to another transmitter that's spoofing it? Maybe a simple replay attack or whatever. Can I pick it up? So these are, I'm trying to say that these can have, RF fingerprinting can be used for very, very important things that protect us all in various things. Remote surgery, for example, talking about assisted surgery in a remote area. You want to be pretty darn sure that what you're talking to, when you're getting, the doctor is getting the information, that's coming from who it's supposed to be coming. And again, and RF fingerprinting can help that. I'm sorry to get on the soapbox, but I had to say, Amie, wait, now I have all those concerns too, but there are some positive applications as well.
And so, and it sounds like, based on some of your examples there, that RF fingerprinting technology can be used across a wide variety of devices that have RF, communications. It's
basically anything that transmit. Now there's passive eavesdropping, or what we call sniffing in the business, where I can just listen and I don't transmit. If I'm just listening, I don't have a transmitter, and I'm gaining information by just listening, then it has to have the transmitter, because it's the transmitter characteristics that I use to uniquely identify that device.
And then just to, is this the case where in order to identify an RF fingerprint, I'm assuming that you will need, it's not like you just need a phone to do that. You would need some sort of rig in order to pick up that RF.
Yes. That's right. Let me give you an example where if in an ordinary, I think I said this before, an ordinary push-to-talk radio like police use and stuff, when you push the talk button, the transmitter at first is trying to find the carrier frequency that is trying to set the carrier frequency on which it's going to transmit at. Well, it doesn't do that instant. It has to wander around a little bit before it gets to the right frequency. And every transmitter, push-to-talk transmitter, has a unique way of sort of turning on. So all I have to do is look, is this pattern, how it turns on, match another, and I can tell whether that is a transmitter that's being spoofed. And this is actually, and you don't, to do this, you only need a spectrum analyzer. Really, I can take a look at the spectrum and I can see how that transmitter turns on, and I can compare it with the other. And so I don't need sophisticated equipment to be able to say, hey, this was the person who had this device was causing this interference.
Okay, so as we would say in the wireless industry, the barriers to this are very low, meaning that you can do this kind of thing with relatively standard equipment.
Well, in the reading material, especially with software-defined radios and so forth these days, you know, it is just incredibly simple to go into the lab and build any kind of radio you want, any kind of device. I mean, so that's one of the problems we've got, is that but I mean, so little is done in hardware anymore. So much of it's done in software. But the part that's done in hardware is that last stage where you take those digital signals and you then analog and you send them out and you have an amplifier and so forth. That's where the identification that we're talking about occurs.
Got it. So now we've gotten some really good questions and comments in the chat. So I want to turn, instead, like I said, I've got this big long list of questions, but I'm going to turn there now, and I'm going to start at the very top. Our very first comment inside of the chat. It talks about the notion of being able to use with millions of devices out there, can you still do a targeted attack with RF fingerprinting? I think is sort of the basis of this question and this comment. And so maybe Amie or Dale, if you want to sort of address this notion, but when you talk about RF fingerprinting, you know, is this, can it still work in an era where there's, you know, thousands or millions of devices out there operating in a, you know, inside of a convention center or something?
Let me start. Say there's it depends on your scenario, but the literature you look at, they can go up, you know, to have tens and thousands of devices. But I don't know whether to believe it. Set that aside. If you're trying to protect a military base, for example, when you go through the guard gate, it takes a look and finds your RF fingerprint, if you will. And then if you move around on that base, you have your RF fingerprint. So all you have to do then is have a receiver someplace else that takes a look and says, is this a device that I recognize that should be in this where it is? So I'm evading your question a little bit, but if you look at the literature, it looks like you can make, with, you know, cloud storage, all the things we can do now, you can collect an awful lot of these RF, in theory anyway, collect an awful lot of these RF fingerprints. And
go ahead, Amie.
Just one thing, again, not an engineer, just a lawyer. But I, as I go through this, one thing that I always feel like I need to point out, if you're studying the technology, you need to know what the limitations and what the uses of the technology are today and how it can be used in device-heavy environments, cities, urban areas, to pull out one device from thousands, if not millions, within a space. Looking from a regulatory or policy perspective, I always urge people to pull back from that a little bit. The material, the literature talks about privacy in terms of today's technology, which, as we all know, develops very, very quickly and can improve way faster than the law improves. We still are using an internet surveillance law from 1985. So like we're way behind the time. And so I discourage people from thinking through what could be legal or policy solutions based on the limits and the uses of the technology in current terms, and more about what its potential is and how it can be used 10, 20 years in the future.
And Amie, I wanted to follow up with you on this. This is a somewhat related topic. So, you know, as a journalist, I learned in journalism school that when you go to a public location, you know, Central Park or whatever it might be, it is okay for you to take pictures of people in that location because they are in a public place, right? And so you can't go in, you can't sneak into their backyard and take pictures of them there because that is a private place. Now, my question for you is, you know, with this idea of thousands and millions of devices out there, you know, tracking them in a particular location. Now, if I go into the Colorado Convention Center or somewhere similar, it is okay for them to take pictures of me in that location. Is it also okay for them to get my phone's RFID because I have entered into a public location? And I realize that this is new technology, the laws do not, you know, catch up that quickly. But I mean, just in general, like, is that an argument that would be made, and is that a concern that, or does that not, is that not related at all?
So I hope you'll allow me to digress a minute, because I think this is fascinating. There's this cycle in privacy where a new technology comes out. Everybody is really worried, alarmed, concerned, raises some fears, gets into the public use. People start to see the benefits. All of those concerns go away, and we keep going with our lives. And it happened with photography. When the Polaroid came out, when you had these instant quick use cameras, people were really concerned about what that would mean for their everyday lives. And there were bills introduced to limit public photography. And then the concern went away because public photography is great. And it meant you could take photos of things that you wanted to keep memories of. But maybe that wasn't the right path, because later on we had to tack on protections against paparazzi, against following people with cameras. Where was the public and private space? So with this tool, we again ask what is public, and you said, can they go into the convention center? First of all, under the law, the they is very important there. Can the state or the police go into the convention center and do this? That's a very open question. We have cases at the Supreme Court, starting with US v. Jones in 2012, and kind of very slowly over the last almost decade ramping up, where your location, the Supreme Court has found constitutional protections in tracking your location over time, vis-a-vis the state. Now, that has been a very slow process. It's unsure what the contours of that protection are. But generally speaking, it's always safer if the police are getting a warrant or some sort of process. Private companies, we don't have a federal law on what private companies can do in the US for the most part from a privacy perspective. We have some sector specific laws, financial, children, but there's no overarching law. So there are very few limitations on what a private company could do, so long as they're not being what the FTC, the Federal Trade Commission, would call unfair or deceptive in their practices. So very different days. But this is why we need to be thinking about, again, what this technology can do in the future to get those protections in place now.
Gotcha. And in that case, I'm just going to assume that Facebook is already using this RF. That's just a joke, but I'm going to assume it. I don't know for sure. But, so now I'm going to move on to another one of these questions that came up in the chat box and in here in the comment section. Again, if anyone has a comment or a question, go ahead and type it in now. We'll get to it in the time that we have remaining. So Dale, I think this is a question for you, and I actually had the same question written down. The question is sort of in the middle of there. It says, Dale posed cellular carrier example of malicious interception of communications. How do the carriers confront that problem today? And so you can scroll to that in the chat function. And here's a guy that's got a timestamp, 11:39 a.m. So Dale, I wondered if you could address that question, and also talk about, like, how does in the case of a cellular base station spoofing, presumably there's technologies to sort of protect against that Stingray scenario now. Maybe you can just talk about that in general.
Not sure I completely understand, and let me buy some time here by saying that one of the difficulties we have is finding out what the carriers are actually doing, and this gets into the transparency issue and so forth. So I have asked directly quite a few people, and I don't get clear answers as to what steps are being used. If you look at the list of materials I sent, there was a couple of press releases by carriers in the early days talking about exactly using RF fingerprinting as a part of the authentication step, which this device, which what we're talking about is really good. In other words, the carrier wants to make sure they get paid. There's a real incentive for them to, and you can get information. Is this the phone? For example, if the phone was a different phone, maybe because there was a lot of heavy subsidy to the phone or something, and somebody substitutes another, and now you can figure it out because you can look at the RF fingerprinting, and here again, to pick up a lot of this is a lack of transparency as to what is going on. The difficulty that we have in the academic side, and I would say, and generally speaking, in public interest groups, more generally finding out what the current situations are. Did I duck that question? You're used to that, Mike.
Yeah,
You're used to
good.
that. You're used to that, Mike.
That's well done. A true pro. No, but I mean, I was wondering, so, I have to assume that the connection, that's why I think the cell phone spoofing is so interesting, is because I have to assume that when my phone communicates with a base station, they basically like exchange secret code words, and like World War II spies would say, the cock crows at midnight. And then the other guy would say, oh, the rooster crows at dawn. And then they would know each other was the contact for that particular exchange. So I assume that a phone and a base station have a similar sort of dance and as they authenticate with each other. And that I would assume that RF fingerprinting could be laid on top of that exchange as a way of further securing it. But I don't know.
That's right. Or over time, the key exchange could be broken somehow over time. And now I've still got this ability to be able to identify the specific phone.
Mm-hmm. Yeah, as another layer.
Could I actually add on to this?
Yeah, go ahead.
This story published as our conversation started. And I thought that I was going to have the most timely example of a really good security use for this technology. And it ended up, as I scanned it, it's a limit on the security that even this technology could provide. So I thought just to mention, this is an attack where it's basically, they took advantage of dumb humans and the fact that humans are human and they're still able to transport a phone number to another phone if they pose as if you're being gamed through customer service lines. And so I think I totally agree with Dale. There are very, very good uses for this technology, both from a security and a privacy perspective. The literature reflects the use to protect people from having the incorrect key get into their car.
Yes,
from a privacy perspective, I don't want somebody who's not me in my vehicle.
Right. Exactly.
But there are limits. I think it's nice to see a story call out even the limits of any device security.
Great. And again, I encourage everybody out there, if you've got a question or a comment for either of our speakers today, feel free to type it in that chat box. You can use the button at the bottom of your screen. I'm going to move on to one of the questions that I had written out. And this is a question, I think, for you, Dale, which is, you know, in a lot of the literature that you had sent out, there's a lot of discussion about using artificial intelligence and machine learning for RF fingerprinting. And so maybe you can just talk about those two specific technologies in relation to this and whether they're required, or is there some other way of running this kind of technology? Maybe you can just kind of explain that.
Well, as I indicated before, to do some of the simple stuff, you don't need much more than a good spectrum analyzer. But if you really want to do this in sophisticated ways, if you want to be able to pick out all different kinds of transmitters and so forth, be able to then that's where the AI ML really comes into play, and deep neural. I mean, all the sort of things we talk about really can be applied here in this area to make it more effective, so that more devices can be identified. We sometimes also talk about classification of devices. In other words, is this a device? Is this a particular? For example, this device is built by company XYZ. That's different than saying it's a particular device, but we can use similar techniques to say, okay, well, we know who the manufacturer was, and now we know who's carrying that device by using the RF fingerprinting. So but your basic point, the AI ML technique just really are crucial to this. If you're taking the attitude that we've got a problem and we want to solve some of these things, like during the remote surgery, we want to make sure we're communicating with the surgeon at the other end and not some imposter.
And I think a related question that I had about this whole thing is, you know, there's been a lot of discussion about dynamic spectrum access. And, you know, as a journalist for the publication Light Reading, which is at lightreading.com. If you're not a subscriber, go there now. Spoilers. I figured I'd throw that in there. Is that so? In my job there, I cover a lot of discussion about dynamic spectrum access. Specifically, the TV white spaces band has that. Abilities. CBRS, the 3.5 gigahertz CBRS band is another one that it's a big deal. They're talking a lot about that. And so I'm wondering, is RF fingerprinting potentially an application that could be used in that area for, you know, even more capable dynamicacy?
Absolutely, and at least the following sense. The SAS, the system that's handing out channels and taking them back, only controls members who are part of the SAS. So, for example, if there's a signal in the band, let's say the harmonic of an FM broadcast station's causing interference, that's not under control. So it could be causing interference, in some cases pretty severe interference, but it's not under control. Now, what do we want to do? It's what I said before. We want to stop it. If this is a critical system, we want to stop it as quick as we can, so that the damage, not too much more damage, is being done. And then, of course, eventually we want to arrest somebody. We want to prosecute somebody for doing that. Maybe now, in the case of the harmonic, you know, one of the trouble us in spectrum management is the cases where both people are operating legally. And so it could be the operator of the FM transmitter is operating legally, but causing interference into the dynamic spectrum system. And I'll leave it to lawyers to sort that out when both sides are operating legally. But I think the RF fingerprinting can play a really critical role, again, in trying to pick them up. And there's a whole policy stuff here about the SAS operators not wanting to be in the enforcement business. There's legal issues of them what rights do they have to shut somebody down that's not part of the system? So there's a whole, I won't go there, but mainly I'm not a lawyer, but there's a whole lot of issues surrounding that.
Okay. Yeah. And thanks. Scott just messaged us about what the SAS is in CBRS. So thanks for putting that into the chat. In a related question I wanted to ask you, so, Dale, you said that this is a technology that could be applied to dynamic spectrum access, such as in the CBRS band. Do you know if there are any commercial uses of RF fingerprinting yet? And then Amie, I'm going to give this question to you as well from a legal standpoint. Has this come up? But Dale, I'd like you to address this first. Is anyone using this?
This is the here it goes back to that transparency comment. Let me say my role in the tech policy arena has always been trying to understand enough about the technology to warn the policymakers and understand enough about what the policymakers are concerned about to be able to talk to the technology people. When we get into the details, here is I regard this conversation as an opportunity to learn more about what is actually being commercially deployed today. Here again, it's like I say, it goes back to that transparency thing. How do I find that out? And like I say, when I've asked direct questions, I tend to get evasive answers. Did I duck that too, Mike? I didn't mean.
I was going to say, boy, that's I know how you feel in terms of getting evasive. That's about 50% of my day.
Yeah.
So, but Amie, I wanted to give this one to you as well. I mean, has RF fingerprinting or any other sort of related technology like this, has it come up in your practice as in any of the cases that you're following, or anything else? Is this something that you're actively looking at?
It hasn't. And in fact, if you look at the literature, the discussion of privacy for RF fingerprinting is very scant. But you can find analogies. We've talked about stingrays or IMSI catchers or cell site simulators, whatever you want to call them. Loose analogy, because that comes up with some interception rules under the Electronic Communications Privacy Act and related laws. And so it's not a direct correlation. You almost would want to look more at, again, back to the biometric laws and how biometrics are collected and used. I'm thinking FBI databases. FBI was taking in fingerprints of people who are providing fingerprints for job interview background checks. And so when the employer provided the fingerprint to get a background check, the FBI was keeping those fingerprints in a file. And in exchange for allowing them to do that, they were telling employers that they would notify them if in the future the fingerprint got a ding. If one of their employees was arrested in the future, they would let them know immediately. And so programs like that, you can see and look at for guidance of how those fingerprints might be collected, particularly by the government, and how they might be accessed in the future. And so even though we don't have direct RF fingerprinting cases so much, we do have things that we can look to.
Gotcha. All right. And now I'm gonna ask each of you to pull out your crystal balls from your backpack and put on your wizard hat and pretend that you know what's going to happen in the next 3 to 5 years, and maybe just give us a long-term view of we've been talking about RF fingerprinting technology. If I were to press you with your best guess about how we will see this technology put into action, what would you say? And I think, Amie, I might give this one to you first, and then Dale, I'll have you follow up. But just based on the cases that you're seeing and just the general evolution of technology that you've been watching, if RF fingerprinting were to show up, where would it show up?
So I think that there are two places we'd see it first. This is not my ideal world. You kind of alluded to your ideal world. So I'm going to pull back from that a little bit. There are two places I think we'll see it. One is state use. Police want to know where people are, and in particular in public spaces. And I think that there are really good use cases for why in some circumstances they should know where some people are. And I think there are really horrible ways that we've seen law enforcement track individuals. And so I would urge us to look for a federal location privacy law. It's just going to expand the need for it that we already see in current technology. The second one, because if there's a new technology, the second thing you're always going to see it used for, we all know what the first thing that new technology is used for. The second thing is advertising. And we talk a lot online about behavioral advertising on websites. And companies and stores in particular are looking at ways of doing behavioral advertising more in the physical space. And if we can tie an identity that is trackable from one place to another using a device, we're going to see more of that behavioral advertising, more tools like this used to conduct in-person behavioral advertising, I believe. And I can see that use very, very clearly. And we're still fighting about basic data protection rights. One of the articles, if you want to tell a privacy person, if you want to like make their heart stop, tell them that consent is good enough. They think that by using this device, you have informed consent to give away this information. And I would strongly push back against that and think we need to really put use limitations in place for how these tools can be used. You can't just say somebody's consented because they use a cell phone.
That sounds right to me. I agree. Dale, maybe I'll give this question to you as well. If you look 3 to 5 years down the road, where do you expect this RF fingerprinting to pop up? And I think you may be muted.
To add to Amie a little bit, is I see it mostly in critical infrastructure situations where attacks can have rather devastating effects. So in general, I would put it at critical infrastructure. And here again, I keep using the GPS as an example, but even the if I understand it, even a lot of the encryption stuff depends upon critical timing. It eventually comes back in many cases to GPS to get the critical. So if you disrupt GPS, you can really cause a lot of problems. So I think GPS, well, you've heard me say, as we move increasingly to wireless, which we all like because of all kinds of reasons of convenience, we're at the same time making ourselves more vulnerable to attempts to disrupt it. And I have pardon me for reading something, but going back to the dynamic spectrum sharing and so forth, the SAS and so forth I was talking about, those systems kind of are based on the people will play by the rules, right? They'll play by the rules, but here's my list. The assumption may be invalid when individual criminals, organized crime groups, foreign powers, non-state actors, disgruntled employees, and activists who may be motivated by financial gains, grudges, political advantages, and even military advantages are involved. So that's, to me, is really focuses, hey, this threat is sort of bigger than we sometimes think about it, because all these are types of people who may have the motivation, for example, to jam GPS. I might Mike, I'm going to do it to you again here by answering a question you didn't ask. But it's really important. It's really important as we think about this, is the government today is faced with a huge number of threats of the type we're talking about. And for example, right now, reading this morning, is it attacks? Is it attacks, ransomware attacks, due to some of these recent breaches that are most thing to spend our money on? Is that where we should focusing, or we should focus it more on the sort of things that I have raised? And that what we need is a risk assessment. We haven't talked about the new administration and so forth. I can talk about that a little bit, but the thing here is we need a risk assessment to figure out where we should be spending the government's limited resources in this area, or to put it technically, where in the protocol stack, if you will. I mean, you talk about ransomware, now you're way up here in the protocol stack. Should we be worried about this? Well, that's where you need a risk assessment to be able to really decide, is this risk so important that we need to spend resources on it, or should we shift? And by the way, I argue that the FCC has a particular role here, because their role is protecting that RF environment, that they're down at the physical layer, radio stuff. And so it sort of seems to fit with the FCC, as opposed to ransomware. Some people would argue, well, that's somebody else's job, not the FCC. So sorry about answering another question, but I really do think it's important that we get some sort of an overall risk assessment, and then that leads to what the new administration will do in this area.
Yeah, I'm glad you addressed that, because I actually did want to sort of broaden that and look at it a little bit more. I mean, we've talked a lot about policy today, and so in the realm of RF fingerprinting, is Dale, you sort of alluded to this. It's sort of, is it mainly the FCC's purview, or is this a Federal Trade Commission, or is this Institute of Standards and Technology? Like what branch of government, or is this a state? Who should be looking at RF fingerprinting?
I would argue a little bit for the reason the FCC at the physical layer stuff, but now you're getting into questions. Should this be handled, at the National Security Council level, in the White House, National Economic Council, because of its economic consequences? So that gets into a lot of what I was saying about what the new administration, how it wants to go about organizing. I think here again goes back that risk assessment and how big we think the risk is. But I think primarily it has to be like I say, at the National Security Council level, type level myself.
And Amie, do you have any thoughts on where this ought to land inside of government, or should it not even be addressed by government?
I mean, I think it's going to land a little bit everywhere. I think Dale is right when he talks about it. I think the National Security Council is absolutely should be addressing this from a privacy perspective. We are looking at the FTC at the moment. When you look at private sector uses of this, is the use of it unfair and deceptive? That's kind of what we're stuck with as a question. And so they're going to have a role. I can see it going through in the future. One of the National Telecommunications Information Administration likes to do these multi-stakeholder processes on privacy that 50% of the time I think have not worked the way they wanted to, but I could see that being a process in the future that they engage in. Depending on what aspect you're looking at it, I can see it in a lot of different places, but there does need to be an agency tasked with analyzing this, doing an initial study, an initial risk assessment, and then maybe even dividing it up between the agencies to deal with each piece of this puzzle, to make sure that the experts in each area are on the case.
You may at this point need to deeper government-private partnerships to deal with some of these issues. And it's come up recently, I think even in the press this morning, about trying to rely, because we've got a problem, we've got a collective action problem here, and something needs to be done, and getting in. Of course, I would add not just industry people, but people for academics and so forth. But nevertheless, I think we need I think we need to address it at that kind of levels.
Okay. All right. And I think this may be my last question from me before we move on to just wrapping up. I'm wondering if each of you could just sort of talk about, if you could apply this technology to one area that you want it to be applied into, what do you think this should be used for in a best case scenario? Dale, maybe I'll give this one to you first. Like, you know a lot about it. What's the best use of this RF fingerprinting?
What keeps me asleep at night probably the most is the GPS jammers. And if you do a quick search on the internet right now, sitting at your computer, you can buy all kinds of jammers. They're absolutely illegal. They're absolutely illegal. The use of jammers, and we need to have ways of being able to say that jammer was in your possession at the time this interference that disrupted so much occurred. And we can get you in front of not just an FCC notice of apparent liability or something like that, sort of toothless, but we can get you into court and prosecute you for the security risks and the so forth. So I would say GPS probably is my number one. Now there's a lot going on over there talking about, reinstituting ELRAN or whatever it's called, some other technologies here, but it's certainly it's certainly needed in the GPS area. And then I would go back to the areas what I listed before, the healthcare facilities and things like that, where a spoofing attack could really cause serious harm.
Okay. And Amie, I'll give this question to you as well.
I 100% agree with Dale. I would just add to my priority list, if it's not already being explored, to explore it. Authentication for security updates and software updates for devices and systems. It's a big area, and governments are increasingly messing with it in bad ways to insert vulnerabilities in encryption to allow surveillance. And it's unclear to the extent companies can resist those orders. And so trying to make sure that you have only legitimate updates coming through to your devices, that they're authenticated by the right people and aren't co-opted in any way, I think is going to be huge, especially with medical devices. And as we see hospitals plug in more and more of their tools and technologies, those are the highest priority, making sure that they're doing what they're supposed to be doing.
Okay, and Dale, one last thing. There was a question that came in through the chat about, in your role at the FCC and then also the Commerce Department. Do you know of any conversations about this technology that are going on in those agencies?
Yes, I got interested in this first because the FCC, the Technical Advisory Council, which I serve on, raised it was raised because of the concerns about the sort of wireless attacks that I'm talking about. So that's where I first heard about it, was in that context. And then, and I wish I could immediately, but the NTIA a while back actually had a proceeding where it said that they wanted a requirement that all transmitters have an identifier associated with them, just like you have call letters from a radio station, that each transmitter have an identifier. Now, that didn't go very far, but it raised the issue. And so there's these two things that are occurring, one on the TAC side and one on the SISMAC side. And those, I think those are the sort of activities that, well, let me back. I think I've lost your question. It sensitized me. It really sensitized me to this area. So there is work being done. First, to summarize, there was work being done in the TAC, there was work being done in the SISMAC, and as the new administration gets its act together, and that sounds pejorative, and I don't mean that to be that way at all, but as they get things settled down, I assume that they will then ask perhaps the TAC in the FCC side and the SISMAC on the NTI side to take further looks at this kind of activity. And maybe the National Science Foundation has a role to play here as well, and the places like the National Academy of Engineers, National Academy of Sciences, maybe they have a role here to play as well.
Gotcha. All right. Well, with that, I'm watching the time click down. I want to be respectful of everybody's the rest of your afternoons. So I'm going to let each of our speakers just provide any closing comments that they wish to provide, and then we'll wrap things up. But I'd like to thank all you computers out there for joining us today, and our excellent speakers. And so with that, Amie, I'm going to turn it over to you. Any final thoughts on this topic, or anything you'd like to share as we wrap things up here?
We need to update ECBA. We need a data protection law in the US. Call your member of Congress. We'll keep it short.
All right, that's fair enough. And Dale, I'll give you the last word here.
My final comment is very self-serving. Like I said in the beginning, there's a lot of very smart people on this call, and people who have access to other very smart people on the call. And if you see additional information you have that I can add, for example, to the list I sent out, so forth, that'd be extremely helpful. Sorry for the selfishness, but I can't help it.
All right, sounds good. I think that's all from us. We'll give you a few minutes left with your afternoons. Thanks all your computers out there for joining us today. Hope you have a good afternoon. Stay safe. We'll see you at the next one. Bye-bye.